Okay, this is the last video, and this is brought to you by for 3-3. This is brought to you by that droid Star Wars guy thing. He's doing his thing. Okay, so what we're going to look at is how long it takes to pay off a credit card if you only make the minimum payments. Our author points out back in 2011, minimum payments had shrunk to the point where it didn't even cover the interest for the month per month. So if you only made the minimum payment, you would be in debt forever because your balance would actually grow instead of decrease. And so the federal government put in some new regulations that required credit cards to set the minimum payment to cover at least the interest in a bit of the principal. So each company is allowed to do that formula however they want. The point there is that credit card companies are required to make a minimum payment such that you are actually paying down the balance. Before that, they didn't have to do that. So we're going to look at a scenario where, let's say you have a balance of $2,300 on a credit card. We're looking at a monthly interest rate of 1.25. Remember, that's not the actual APR. We would do 1.25% times 12 to look at how you will actually see it in the real world. And how the minimum payment is calculated is this interest, you're going to have to pay that full amount each month, plus 2% of the actual balance. And then often there's like another amount, or $20, whichever number is higher. So interest plus $20 or 2% of the balance plus the interest. So we are going to really restrict this scenario. We're going to say that you make no more purchases and that you make the minimum payments from here on out. And note that these are the industry averages back in 2019. They're, of course, different now in 2024. Okay, this is very similar to the Task 3 project of Project 2. So let's figure out the interest. If it's 1.25 per month, let's calculate the amount of interest that you would pay in the first payment. And let me stop using red because that's a very bright color. So in the first month, the amount of interest you would owe on your account balance is this. Let's scamper over to Desmos and find that. So 2,300 times 0.0125. The interest we would pay is $28.75. Okay, so we're going to add to that 2%. So let's calculate the 2% of the balance. So let's do the 2,300 times 0.02. This is the amount of the balance we would pay. Let's see, 1% just moves the decimal 2 places to the right, so it would be $23. 2% would be double that. So it would be $46 is what 2% is. So our first payment in month 1, this isn't what the question is asking, but we're gonna calculate it, would be this $46 plus the $28.75, right? That would be the first payment. The second payment is going to be 2% of this decreased balance plus 0.0125 of this decreased balance. So these numbers are going to go down each month after we make a payment based on what this new balance is. So notice the question here says, what is the new balance after month 1? Well, that new balance is this $2,300 minus only the $46, because this $28.75, we're getting charged that. We're just paying it off before it gets added to the balance. So really, the new account balance after the first month is whatever this difference is. That looks like $22.54. Okay, so after the first month, we would have paid this amount. Ooh, I should be able to do this in my head, right? So it's going to be 75 cents. See, 6 and 8. That's a 4, 6. We'll paid $74, but we will have decreased the balance by 46. Okay, the author says, let's repeat this calculation 5 more times to find the balance after 6 months. Well, in other words, what he's saying is we're going to do this, and we're going to do times 0.02. And at this point, I don't want to bother doing it in my head. I don't like doing any of it in my head, to be honest with you. Why do mental math when we could do calculator math? It's kind of my argument, but also, I don't know. There's fun in doing mental math. Okay, so the next month's payment is $45.08, and the new account balance is that decrease. Now, I'm going to short change this and see if you don't recognize what's happening here. We are decreasing the balance by 2% each month. That sounds like a decay rate from Unit 2. So if you recall, in the exponential problems of Unit 2, we had the exponential equation was y equals some initial amount times some decay factor raised to a time, and the initial amount here is $2,300. That's our amount at time 0. Our decay factor is going to be 1 plus the decay rate, which is minus 2%. In other words, we're going to get 0.98. What this is saying is 98% of the balance remains each month. So we can write a nice little equation using our knowledge of Unit 2 that will model this situation. And it looks like this. Y equals $2,300 times 0.98 to the x power. But we need to note here x is in terms of months, not years. And y is the account balance after x months. So if we scamper back over to Desmos, we can say, hey, what's the account balance after 6 months? And we can answer that first question that we were asked by putting in a 6. Oh, we still owe $2,037.43. Now what we really want to do is change this into an equation. And what I think I really want to do is turn that into a table and get a picture of that and zoom that out a bit. And then what I really want to do is say, okay, my first payment was $74.75. So how long is it going to take us paying just the minimum payment to make the same payment that we made, or for the balance to be the same amount as the first minimum payment? And if you look at that, I graphed both, and I'm getting that it will take 169.60 or 61 months. In other words, if I only make minimum payments, it's going to take me 14.31 years to reduce my balance to the original minimum payment balance. That is a super long time. You're paying that basically forever. The other question then is, how much did we actually pay? And that becomes a particularly difficult question. Well, it's not super difficult. We'd have to do some programming in Desmos or Excel to calculate that. We'd have to add up all these minimum payments. So this payment was $74.75. Notice the amount we paid, the 2%, went from 46 to 45, so it decreased by 92 cents. This amount here, this 0.0125, would decrease by a little bit. So the second month's payment is going to be roughly $1 less than the first month's payment. So we'd have to add up all those payments to see, after 14 years of payments, how much would we have had to pay. Ends up being way more than the $2,300 that we initially borrowed.